topic concluding our examination of REST. In particular, we're going to look at a review of the HTTP protocol. Much of this you'll know already, but just doing a quick skim through it just to make sure we can position ourselves HTTP correctly. And then we look at some REST endpoints we've implemented to date, particularly a range of new ones to do with making donations. Okay, let's start with the internet and HTTP in general. And let's just talk a little bit about that protocol, where it came from, and the kind of features it offers to us. We know we are connected to a cloud. By and large, we're connected client to server when we're considering developing single apps. And this client-server protocol is at the heart of the programmable web. We're familiar with a whole range of these protocols that have been part of the internet since their inception. They've kind of faded from view in the last 10 years or so because we just assume the web is all pervasive. So things like SMTP, POP, IMAP, FTP. There was a time when we all knew these, and we all knew which services we were using, but now we just talk about the web in general without being too specific. But as you program it, well, we must be specific, and it's these area here, web and HTTP and the HTML standard, that we are focused on as we develop our services. Historically, and this even predates the web, we regard a network as a layered model. You may have covered this in your computer networking course. Each layer builds on the layer below. The 7-layer model was designed many years ago and has served well the network architecture community. The analogy is familiar, I think. We imagine some management type person. She's dictating a handwritten message, an assistant is collecting it, correcting it, handing it to secretary who will type it, dispatch to a driver, it's taken to a sorting office, packaged, loaded onto a truck, delivered physically to another location, and then the reverse happens. And here we see the 7-layer model in action. Physical, data link, network, up to transport, session, presentation, and finally application. The idea with the model is that the layers depend on those immediately below, and they offer services to those immediately above. TCP/IP postdates the OSI model, and it simplifies it to a 4-layer model. Application, which encompasses the OSI application, presentation, and session. Transport, which corresponds to transport exactly. Internet, which corresponds to network. And then network interface, which corresponds to data link and physical. So TCP/IP is the protocol, is the networking protocol now we're building on our applications on. Now the application layer itself then has these protocols I mentioned at the start. They're all considered to be part of that group there, including the HTTP standard we're interested in. But you can also see other standards you will have encountered here: SSH, Telnet, FTP, POP, etc. Let's look at it from the point of view of a simple interaction on the web, perhaps using a browser. We click on a link and we get a page rendered in our client. If we were to delve into that in a bit more detail, browser is connected to the cloud somehow, and through the cloud we reach a web server. The client and server are names we give to these, so we consider we're dealing with just two computers, two nodes if you like. First of all, we must resolve our DNS, so we're going either to a cache or a host file, or we may be going out to the cloud to get our DNS service and get the IP address resolved. Once you've got the IP address, we are contacting the server with a sync message. Effectively, we're saying, are you there? Acknowledge, saying, yes, I'm here. And then I acknowledge the acknowledgement. This is what the browser is doing now, and this is the browser interaction with the web server. Then we issue a GET command, we're looking for a specific path, let's say the root path from the server. We get back OK message, and we get back a file, or rather what we regard as a file, the HTML page at that root. That may contain links for further resources we need to acquire, and we might get those individually, and more content is delivered back. Finally, we're finished, and we get a finished acknowledged message. So quite a bit of traffic going on in there just to fetch a simple page, and that's the web in action. When we're dealing with HTTP, we don't go down to that low level. We're just up at the higher level, at the application layer, issuing a request and getting a response. And we're not really too interested in the TCP/IP layer below it. So we regard it as a single request, single response protocol. Now, of course, with AJAX and aspects of HTML5, it's not quite as simple as this anymore. Multiple requests can take place from a given page without a complete page reload. We'll be discussing that in future classes. You're familiar with the structure of a URL, domain name, folder path, and finally file name. And we are, of course, familiar with, and we've seen this now in action with the little APIs we've been building, the kind of structure we can impose in here. We regard it as a path that seems to be identifying perhaps a file, but of course that's entirely notional. And we're able to compose these paths, or URL paths we'll call them, to suit the purposes of our application. And as you've seen from the Node apps we built, there are no files matching these paths, at least not in the static sense. These paths are a logical construct mapping out the, we might call it the namespace of our application. Now this HTTP protocol, it's more sophisticated than we've been letting on. There are a variety of aspects to it, and we might call the components, including request methods, response status codes, request headers, response headers, general, entity, and content identifiers. Don't need to be familiar with all of these, but they are revealed to us occasionally, and their sophistication is quite deep. And we probably do need to be able to at least read them, particularly in the context of the REST client tools we're using. To debug them occasionally and just to keep track of what exactly is going on should anything go wrong. Let's look at some of these. The methods themselves are key, and you've seen these now almost since the inception of the course. We've been talking a lot about get and post. Get belongs to what's called safe methods. They have no side effects, so if you keep calling head, get, tracer options, they don't really affect the service. Sometimes that's called idempotent services. Unsafe ones are going to have a side effect. They're going to make a change on the server. Post, you've seen, we've been using it to submit data to forms. But we also have put, delete, and connect. We're happy enough to stick with get, post, put, and delete from the point of view of the API we're building. The others are more specialized and not really used in API development. Response codes we've talked about before, grouped into numerical ranges. 1xx is informational, 2xx is success, 3 redirect, 4 client error, 5 server error. And the numbers XX do have meaning, and we will see these in some of the reference documentation I've indicated to you. Let's quickly skip through some of these request headers and response headers. Request headers go from and are carried over from the client, the browser, to the server. Facilitate better understanding between client and server. And there's a range of examples you can see there on the right. Encoding, ranges, what I'm willing to accept, what agent I am. Response headers carry information from server back to the client. Contains additional information, maybe a proxy information, location, authentication information, etc. General headers carry information about the transaction, things like keep alive, connection information, intermediate encoding, maybe date times. And entity headers carry information about the content. And here we could be talking about the possible encryption we're using, content length, content range, etc. And content itself is also tracked by a range of identifiers, including the MIME media types you might have heard of in the past. Now, because it's stateless, the protocol is quite efficient, and it means that any given request can be handled by any given server. We're not relied on state being maintained from client to server, a connection being opened and maintained open, for instance. If we do want state, we're using cookies, that is if we're using a browser, and we'll be seeing this in the next few weeks, we use tokens. We exchange tokens from client to server to maintain the illusion of state. So here's an example. I want to get index. If we were to trace into the message, we might see this type of data here, the host we're accessing, the user agent. You'll notice here it says Mozilla. The user agent strings are quite unusual in that they tend to be not necessarily matching the browser you're using. This one originates from Chrome. That's for historical compatibility reasons. You can see the browser here is saying what kind of data it can accept, the different image formats it supports, the language, and the character set. The way this is structured is that the first line contains the actual method name, along with the resource identifier, and the full path could be here, and the protocol. And then the remaining lines on the example talk about the various headers we've just talked about. They're a representative example. Parameters are fairly critical, and particularly as we build an API, we want to accept data from the client. We want to carry information about a donation, for instance, or about a candidate we want to create. And there's two ways they can be passed over in this context. We can pass them in as part of the URL, or they can go as extra request data. Here's an example of them as part of the request chain. And you may be used to seeing this type of thing when you're using a browser. Just draw your attention to this part of the URL here. After the question mark, we seem to be passing name-value pairs. Name and OK. Name is Mr. Nobody, OK is 1. We're passing those as part of a GET request in this instance. This could be a result of a form we've just filled out. If we use POST, then the information is passed as part of the body. So same information here is issued and delivered down here. Okay, so this is perhaps slightly more readable. The POST request just contains the path and protocol version, and we're packaging up any data we want as the body of the message. We've always been taking this approach, and we don't really use GET to send information, at least not when we're building an API anyway. Some examples of the response here comes back on the first line, protocol number, and the response code, maybe a response string as well. And in this case, it's not an API, it's just a conventional page GET request. We're returning the body of the page. The page appears as the body of this message, which the browser then assembles and renders in a viewport. Just to give you an example of some of that in action, This is our donation app. We've logged in, we've got a report running here. Our application now at this stage supports both a web interface and an API. Here I'm requesting the API/users. If I want to plunge in and see exactly what I have received, I can select the network tab in the Chrome Developer Tools. This is the message users that I've just triggered. I can click into it, and here I'm seeing the headers I was just discussing. This is the request URL method, return, the addresses and so on. Response headers of various kinds here, request headers, and you can see a general idea here. Preview the message. In this case it's an API, so I'm seeing the actual data has come back. Response raw here, and any cookies or timing that might have been involved. Similarly, I could do something similar here. If I look at the request response in the case of issuing the report, here we're seeing considerably more activity, including a range of other responses. You can see some redirects here. This is us fetching the various CDN resources to do with our JavaScript libraries. We've seen one rejected here, so we're still carrying around a badly named style sheet from when we started. We're getting correct responses here from all the finally delivered style sheets and so on. And if we dig a little bit further in, we might be able to see the body of our message. Okay, that's the basics then of it. Sorry, here's the body of our message. Here's HTML coming back. Here are the headers. You can see the cookies being exchanged because I'm logged in. Preview of the text that's come back, as well as the body, the HTML page, and the actual response itself just on its own. Right, that's general overview of HTTP protocol. A lot more detail we could go into on HTTP. To build an API, we're happy enough though that with just the knowledge we've acquired, we can start to work meaningfully with the API. We are working in the application area, and we're effectively repurposing an application protocol, HTTP, which is designed to be used initially with browsers, to be used as our API transport for general purpose services we develop. Okay, we'll come back in a moment and we'll talk about our API, particularly the REST API we've been starting to build in more detail.